increase is in the developing countries, the Asian countries, South America, and Africa. This strongly suggests that something in the environment has changed. Some of the possible environmental influences include diet, which has dramatically changed with refrigeration, processed foods, and fast food outlets, increased fat, decreased fiber in the diet. And as Western diets move to Asian countries, the incidence of IBD has gone up. Another possible environmental factor is the widespread use of antibiotics that have altered the gut microbiota, and including eliminating parasites, which can have protective influences on the mucosal immune response. Clearly in animal models, it would appear that certain, but not all bacteria, stimulate aggressive immune responses that lead to the tissue injury. Yet other microbiota are protective. One very interesting observation is that in patients with Crohn's disease and ulcerative colitis, and in fact animal models of chronic inflammation, the protective bacteria decrease while the aggressive bacteria increase. And so we believe that the balance of the beneficial and the detrimental bacteria are critically important in determining whether a person develops chronic inflammation or has a lack of developing inflammation. It is my belief that genes are important. They're probably essential, but alone are not able to cause disease. And the evidence for that is that monozygotic or identical twins in Crohn's disease have only a 50% concordance, meaning that if one twin has Crohn's disease only 50% of the time, well, the other twin have Crohn's disease. And in ulcerative colitis, that concordance is only 10%, showing that there are important gene-environmental interactions, that there are environmental triggers that cause someone with a genetic predisposition to develop disease. I think the greatest advance is in how to manipulate that balance of beneficial and detrimental bacteria. One area that's intensely interesting is fecal microbial transplant, or FMT, in which feces from a normal individual can be transplanted into a person with disease. This has worked incredibly well with a chronic infection that relapses called Clostridium difficile. Has yet to be proven in Crohn's disease and ulcerative colitis, but some trials look very promising. I think that beyond fecal transplant, probably determining an artificial group of bacteria that can be transplanted will probably be the ultimate answer, because this will be more precise, it'll avoid the potential of infection, and it lays the foundation for individualizing the manipulation for a particular patient.